Hi everybody, my name is Ahmed Razek. I'm about to interview Jeff Clune from Uber AI Labs. Hi Jeff.
Hello.
So what's your job title and your current role?
So I have two hats at least. I'm a senior research manager at Uber. After Uber acquired our startup Geometric Intelligence to create their artificial intelligence lab. So we've had the wonderful opportunity of kind of standing up a research lab within a big company. And I'm also a professor, the Harris Associate Professor at the University of Wyoming.
Okay, great. What first sparked your interest in AI?
That is a question that dates back to when I was young. I think I honestly can't conceive of not being fascinated with AI. There's a great quote from Richard Feynman which says that I can't understand that which I cannot build. And so for me, doing AI research is learning about how thinking happens, how my brain is able to do the amazing things that it does. And so I'm fascinated in trying to learn about where intelligence comes from, where our emotions come from, where our ability to reason comes from by trying to build it in machines. And it's astonishingly hard, and every single time that I build something and it works, I learn something, and every time I build something and it doesn't work, I learn something. So it's a lifelong quest for me to just understand more and more and more, and the best way to do that is by trying to build it.
So what does a typical day as a research scientist look like at Uber AI Labs?
Yeah, so the typical day is, especially in Uber AI Labs, which has afforded me the ability to do all science all the time, is really a journey in learning and trying ideas out. So learning happens when you get to read the wonderful papers being done by other people in the community, or you get to listen to what other people in your lab are working on and what they're struggling with. But as you read these ideas, or you think about how intelligence might emerge in a computer, or how evolution produced the wonderful diversity in the world, you start to say, well, how could I trigger that? Like, what are the conditions I could create that would allow for the emergence of intelligence within one agent or within a population of agents like happened on Earth? And so that just gets you to start asking question after question after question, and then you go looking for answers to those questions. And the good days are sitting in a room with a whiteboard and a marker and drawing up ideas. I think this will work, and other people will be like, no, that's not going to work for this reason, and you counter with, well, what if we did this? Or having a new idea and telling somebody and then having them come up with an interesting wrinkle on it that you never considered. So we spend a lot of time talking. We also spend a lot of time looking at data. So we conduct a tremendous amount of experiments. And so we're constantly looking at charts and plots of how our algorithms are working, or whether or not what's not working, and thinking up, why is this not working, or why is it working well, and what can we tweak to make it work even better. And this very kind of iterative process of trial and error where you're testing hypotheses, learning what's working, what's not working, coming up with, well, maybe we should try this, et cetera, and just kind of like slowly working on whatever you think to be the grand challenges that are within striking distance. And then there are also fun days when it starts to work, and you start to do like you pump your fist in the air, and you do high fives and fist bumps, and you go get drinks, and you just have a big smile on your face, because sometimes, it doesn't always work out this way, but sometimes you set yourself a challenge and you work on it for years and years and years, and sometimes you actually solve it.
What was your last kind of high five, fist pump moment? There's
a clear one, without a doubt. So I've had a white whale personally, which has actually been a white whale for much of the community as well, which is solving this game, Montezuma's Revenge. And there's been, I don't know how many, probably maybe a couple hundred, or at least dozens of papers by the best minds at all of the top institutions, DeepMind, OpenAI, Berkeley, Stanford, and everybody's trying to solve this game. And it became a personal white whale of mine, because I just knew that it should be solvable. This shouldn't be that hard. And everything we tried, it's complicated as a god, and never worked. And then recently, we had a resident actually come to our lab, and my former PhD student come to our lab, and an idea that my PhD student at the University of Wyoming had kind of merged well with some of the ideas that the resident had, and with collaborators. So that's Joost Huizinga and Adriana Cafe, along with Joel Lehman and Ken Stanley. We got together and we started working on it. And basically in November, we solved the game. And typical scores are for this game so far, despite all of the best efforts of the community, are around like 11,000, and our best network score is 18 million.
Okay.
Just crushes the game. Like, now there are some caveats, and we use a particular version of the game, et cetera, and we make those caveats in our academic work. But in my opinion, for all intents and purposes, basically we've solved the game. And it's rare to say, like, this was a grand challenge for the community and for me personally, and that white whale is now in hand.
So I just want to reflect upon Uber AI Labs, and you are a founding member of AI Labs. How did the lab start? What were your initial goals? And what's the aim of the lab?
Right. So the genesis of the lab is the startup that we had called Geometric Intelligence.
Yeah.
And it was comprised of a bunch of professors, Gary Marcus from NYU, Zubin Garamani from Cambridge, Ken Stanley from the University of Central Florida, along with the founder Doug Bemis, quickly joined by Joel Lehman, myself, Jason Yozinski, Eli Bingham, and a bunch of other very talented PhD students, postdocs, et cetera. And so we had a research group, I think around 15 people, based out of New York City, and Uber acquired us to create their artificial intelligence lab, to have a turnkey research lab within Uber, but also to acquire some of the technology that we had been working on. Once we got here, we all kind of moved out to San Francisco and set up shop, literally, and created within Uber this research lab who's has a twin mission of pushing the cutting edge of artificial intelligence forward, inventing the next generation of algorithms, but also kind of identifying areas within Uber where we can apply the cutting edge research that's being done outside of our lab, but just by the community at large because we're experts, but also by harnessing the technology that we're inventing to solve business problems within Uber. So it's a wonderful opportunity because what Uber recognizes is that machine learning is at the heart of everything that Uber does. Almost every major challenge within Uber, from matching riders to drivers, to getting drivers to make the most amount of money for every hour they put into the system, to driving down costs, predicting traffic, keeping people safe, matching multiple riders together who want to go in the same direction. All of these things are machine learning problems. And so the better we can make AI, the better Uber will be, and the lower costs we can provide for the world, and the more we can take pollution out of the air and cars off of the streets. And so they want us to push the limits of machine learning because they will benefit, and they also want us to spot opportunities within the company where we can deploy this technology to improve almost every aspect of Uber. So it's a wonderful opportunity to both do basic research but also have an impact, because if you solve a problem at Uber, the solution is suddenly in the hands of millions of people across the world.
Yeah. So what are you currently working on right now, and what problem are you trying to solve?
Right, so I lead a research group within Uber AI Labs that's really focused on the side of pushing the cutting edge of machine learning and artificial intelligence, really trying to invent the next generation of algorithms that will allow previously unsolvable problems to become solvable. So I just gave you the one example of exploration and reinforcement learning. That was applied particularly to one video game, but that video game is representative of a very large class of problems that many industries face, which is, how do you get a machine learning system to basically figure out the solution to the problem on its own? What you don't want to do is have to sit down and specify exactly what the algorithm should do at every single situation, because at that point you might as well have a human do it. And often humans don't know how to solve these problems. I don't know how to write the code that can cause a robot to find survivors after an earthquake, or to optimally match riders and drivers within the Uber data system. It's just too complicated. So what I want to do is an algorithm to figure it out for itself from data or from experience in the world. And so we work on those kind of problems to kind of really push things forward. And more broadly, I think about what are the things that AI is currently not good at, and can we make them better? How do we solve those problems? How do we level up AI ultimately till it gets to human level intelligence or beyond?
What is AI not good at for you right now?
Well, one of the things it's not good at is figuring out how to solve problems when it doesn't get a lot of feedback. So if I basically had a robot right here and I said, go fetch me a beer, or help my grandmother do her laundry, or find survivors after an earthquake, it wouldn't be able to do it. Another problem is AI is extremely inefficient in terms of it needs a lot of trial and error, whereas a human child might solve a problem very quickly with just a few trials, or be able to watch somebody else solve a problem and immediately emulate what they do. Our algorithms tend to just take millions of repetition. I mean, Ilya Sutskever just gave a talk in which he said that they can play Dota, or you can learn to play Go, but you probably do it like 1 million or 10 million times more inefficiently than a human in terms of learning how to do those, to accomplish those feats. So if you want algorithms to rapidly learn, then they need to be more human-like in terms of learning fast. And that's another thing that AI is not good at.
So I want to touch upon your presentation. So in your presentation, you spoke about the new algorithm, Go Explore.
Yeah.
What's the goal of the algorithm? What is it trying to solve or improve?
Right.
And how can it be applied into the real world?
Yeah. So the idea behind Go Explore is to help a certain kind of machine learning called reinforcement learning. And so this is when you're not going to tell the algorithm what to do in every situation, step by step. You're not going to label it and supervise it at every single tick of the clock. You're going to give it these high-level goals, like I've been giving examples of, such as go find survivors after an earthquake, or fetch me a beer, or clean the living room, or whatever it is that you want the robot to do. And it has to conduct a kind of an exploration process to figure out how it is it's going to solve that task. So you can imagine that if I told a robot right now, please go find survivors in this building. Let's assume that there's been somebody that's hurt. It has to figure out what that means. It has to learn how to walk. It has to learn how to open doors, ride elevators, climb stairs. It has to figure out what a survivor is, what they look like, and it has to figure out how to find them and then come back and tell you about that. And you don't want to have to sit there and tell it how to do each one of those things. You want it to just kind of like explore the world much like a human child does. So if you think about human children, what do they spend a lot of time doing? They're exploring their world. They're figuring out, can I walk on my tippy toes? Or what are doors? And how do I open them? And how do I get into the cupboards? And can I do cartwheels, et cetera? And so we want algorithms that make our machine learning systems curious so they can explore the world and the problems. And as you've seen a child, maybe you've given a child a kind of an abstract task. And they do a lot of trial and error, and eventually they solve the problem, and they either, maybe you say good job. Well, that's their reward signal. And once you tell them that, then you want them to lock in and figure out what did I just do that caused that success? How can I replicate that over and over and over again? And we want our algorithms to do that. So Go Explore is specifically designed for these problems in which algorithms, we want them to go out and figure out how to solve a complicated problem when they get very infrequent feedback as to what to do. And the algorithm basically is a completely new way of thinking about this problem, which is that I should accumulate all of the interesting things that I've ever done in some giant kind of growing library, and then I will pick one, I will go back to that situation, and then I'll see if I can take it a little bit further. So if you think about something exploring a house, it's going to first figure out how to get to all the adjacent rooms, and then from there the adjacent rooms, and then from there the adjacent rooms, and eventually it will have figured out how to go throughout the entire house. Along the way, if you think about the skills it's had to learn to do that, it had to figure out how to climb stairs, open doors, maybe use elevators, maybe walk on snow or gravel if it went outside of the house. So it's learning skills while it's figuring out how to expand its sphere of accessible locations. And eventually it might find that, oh, there's a survivor outside, and what I should do is come back.
So how have improvements in reinforcement learning helped?
Helped in terms of the world and the applications?
Yes.
Yeah, right. Well, in truth, supervised learning is one type of machine learning, and it has had tremendous applications throughout much of the industrial world. It's really, really moving the needle a lot in things that are improving people's lives. There are select examples of where reinforcement learning has been applied and has really helped, but those are far, far fewer. So to some extent, I think that the era of reinforcement learning making the world a better place is yet to come, and maybe is just beginning. There is an example, for example, where Google used reinforcement learnings to optimize their compute centers, and so they could lower the cost of heating and cooling and running those compute centers and lower the energy footprint. Obviously, AlphaGo was driven by reinforcement learning, which advanced state-of-the-art in Go, but that's somewhat of an academic exercise. But to some extent, that's why I'm drawn to reinforcement learning, because it doesn't quite work yet. But if we can unlock it, it will be an extremely powerful force that can make the world a better place in almost every area that you can think of.
Where do you hope your work will have taken you in the next 12 months?
The next 12 months?
Yes.
Oh, that's not too far into the future.
Okay, then let's extend it to 12 months to 5 years.
12 months to 5 years. Well, in the very near term, we've announced a number of projects that we're particularly excited about. One of them is Go Explore, and we want to do some specific things there. We want to demonstrate it on a real robot and show that it can do the kind of things that I'm saying that I think that it could. So get it out of the video game world and into the real world.
Yeah.
We want it to handle some conditions we haven't yet shown that it particularly applies to. And we basically want to apply it to as many problems as possible to show that it is as powerful as we think. We also introduced the first version of this algorithm, so we want to enhance it. There's lots of ways that we think we could enhance it to make it even better. So that's exciting times. We also recently introduced another algorithm called Poet, which I'm particularly excited about because, as I've been saying, machine learning systems typically need a lot of supervision, the ones that currently work, and they don't work as well without that supervision. And so training data and the right kind of environments in which to train these agents to learn skills is usually the key to success in current machine learning. And typically that's done by humans. So a human says, oh, I think you should practice this skill next and go and try this environment and then this version of this video game and then da-da-da-da.
Yeah.
But that's not what we want. What we want is an algorithm where you flip a switch and it just kind of computes for a while and comes back and asks you the meaning of life. And figures out how to do all these hard skills. So what we figured out in Poet is an algorithm that can generate its own training environments and simultaneously solve those environments. So it basically creates its own set of problems and challenges in training environments and its own data, and then it learns from that data, gets better, and then the process kind of feeds on itself. And again, it's just this expanding set of skills and knowledge and types of environments that it can solve. And so we really kind of want to continue to push that direction as well, which are algorithms that start from a set of initial conditions and then generate their own data, learn their own algorithms, maybe learn their own architectures, and ultimately kind of bootstrap themselves up from nothing into general intelligence. And so that's within the 1 year time frame.
Okay.
So it's going to be a busy year. And that's just two of our many projects. There's many other projects we have. But there is maybe a more ambitious philosophy, which I have been working on and I'm planning on writing up as soon as I get a moment. And that is the idea that at a very broad level, I think that what we really want are general AI generating algorithms, which is to say, I want an algorithm that can generate a general AI entity. I want to hit a switch and have it, like I said, come back and have solved the hardest problems in machine learning. And that means that we need to think really hard about how to get everything learned simultaneously. And so you want the thing to learn the learning algorithm, the architecture, and generate its own data. And that's kind of a more ambitious plan. And Poet, which is the algorithm I just mentioned, and an algorithm that we're going to post very soon, all of these things are kind of in this direction of really trying to push on AI systems that continuously improve to the point that they surprise and delight and impress us without any human intervention.
Wow. Okay, so let's go to some advice. There are many high school students or university students here today. What do you think we can do to encourage the next generation to explore AI and get them into AI?
Right. Well, I would say first of all, to anyone who is a parent or a young child, try to recognize if there's something that you love that is technical or mathematical, or it's a puzzle, or it's an engineering skill. You might do something like build a clock out of parts, or take up something apart, or want to see what happens if you take a flamethrower and burn down a tree, or whatever it is. If you get that little smirk on your face, you probably love science and love engineering and love exploring, and try to quench that technological thirst. Don't give up on that. Don't say, oh, that was cool, and then go back to TV or whatever. Seek more abilities to learn skills, learn math, learn statistics, learn programming, so that you can kind of invent. Make a hot air balloon that can fly around your backyard, or that a balloon that goes to space and takes pictures and comes back down. Whatever fun challenge. If you want to make a catapult that shoots watermelons across your yard, don't let people tell you that that's not a good idea. Insist that somebody takes you to a place where you can build that watermelon shooting catapult or whatever. So Because I recognize in my own childhood that there were so many times that I brushed up against science and technology and engineering and had a great time, but then I didn't know how to push for more. And had I been able to do that, I would have been able to get on track, I think, faster. So for teachers and students, or teachers and parents, if you see that in your children, create those opportunities for them. Another thing I would say to people is that everything worth doing is hard. So, if math is hard for you at some point, don't give up on it. Math, many people will tell you, oh, math, that's hard, you shouldn't do that, or if you can avoid that, that's like painful, like, there's no practical value. That it couldn't be farther from the truth. Math is like going to Hogwarts and learning spells that allow you to make magic in the world. Right? And you watch Hogwarts, like it's hard sometimes for them to learn these spells, except for Hermione. She seems to get it, right? But don't let Hermione make you think that it doesn't take work. Most people have to work to figure out how to make magic. Yeah. But math, engineering, statistics, programming, these things are effectively like learning magical abilities that allow you to do amazing things, like have a robot that cleans up your bedroom for you. Like, how cool is that? If that's what you don't work on, then you have to learn math and programming. And so recognize that these things are, they're the ability to do amazing things in the world, and they're fun in and of themselves. And there's these cultural stigmas against getting into them, or like these notions that, oh yeah, those things aren't fun. But question those assumptions. Maybe it is actually fun. It doesn't, just because it's hard doesn't mean it's fun. And so don't give up. Don't let the world talk you out of getting good at these things, because they are really the enablers of magic.
Fantastic. What have you enjoyed most about the summit today?
I really enjoyed a lot. I enjoyed the talk from Google Brain Robotics. I enjoyed the talk from the student from Berkeley AI, from Ilya. Those are the only talks I've caught so far. But I think what I've enjoyed, this is my second rework conference now, and what I really enjoy is that while the audience is not really from the machine learning community, the audience is extremely ramped up on machine learning. So these are industrial practitioners that really know what's going on in machine learning. And so you can spend your presentation diving into what's really cool and at the cutting edge, as opposed to spending most of the presentation just giving kind of the generic background material that you would give to the general public. So this is a wonderful opportunity to talk to the people who are knowledgeable about what's happening in the cutting edge of research, but are applying it within companies. And so I actually enjoy learning from them about what challenges are they having when they deploy these algorithms, because that gives us inspiration to go back to the drawing board and fix those problems.
Fantastic. Where can we keep up with the work you do?
Two places. So at the university, my lab has a website, evolvingai.org, and we post all of our work there. And then the other best place is the Uber Engineering blog. So every time that we have a new major paper or announcement, we write a blog post and put it on the Uber Engineering blog. But the single source to get everything, at least that comes out of my teams that I work on, is on Twitter, where I'm at Jeff Clune, and I always post all of our work there.
Thank you, Jeff. Lovely talking to you.
Lovely talking to you. Thanks for having me by.